Welcome back everyone to the Hello World Guide. This is another episode of the C programming series, and in this video we are going to learn about creating a makefile to effectively compile our C programs without much problem. So if you remember, in the last video we separated our program into a main.c and a functions.h file. Now creating a header file and having the function implementation here is not the best idea. The reason is that if we include this header file into, let's say our program is made up of multiple files, and if we include this header file in multiple files, then this function will effectively be defined twice, and that is a big problem, because that would mean that the function is defined twice, and C does not allow us to define the same function twice, of course, and it will give an error, and the compiler will not generate the file. So what we want to do is we want to change this. By doing this, that the header files generally in C, this is the most common pattern when you are writing C programs, is to have header files only contain function prototypes, the actual function header, and nothing of the implementation, because there are many times when you don't want the user of the function to actually see the implementation. You only want the the API to be available to them, not the actual whole implementation of the function. So we can just look at the functions.h file and see what functions we have, but we don't have to worry about how they are implemented. So we generally, in header files, we only create the prototypes, and we have a separate file that actually contains what we want to do. So what we will do here is we will actually create another file called functions.c. Generally what we do is that functions.h and functions.c contain so we just create a file with the name with the header file, and then we create a C file which actually has the same name as the header file, only a changed extension, and that file is supposed to, of course, include the header file here that it belongs to. So we will say hashtag include and functions.h functions.h, like that, and this file actually contains the implementation. So I'm going to go ahead and copy this implementation, and let's just go ahead and paste it here, like that, and that works. And we are also going to, because we are actually going to just go ahead and remove this here, and we are just going to put a semicolon at the end of this. The struct definitions are generally put in header files if you want other parts of the program to use them as well, so it's generally a good idea to put that in a header file. And we don't need to include stdi.h because we are not actually using this in here, but we do need to include it here, like that, on a separate line. So that works, and you can see we can add as well, and this is basically what we want. Now if you were to, we are including this here, but there is a problem now. So if I went here and I tried to compile it saying gcc and I just said main.c, then you can see that it will actually give an error and exit. It will say undefined reference to add, and it will say that the LD is the linker, and we will learn about this in a second. And you can see it gives an error saying that the reference to add is undefined. That's because we are only including the header file and not the actual implementation. So it knows that a function called add exists somewhere, but it doesn't actually know where it is. So it just assumes, okay, it must be somewhere, and when we are actually compiling we will discuss that. And we go ahead and do this, and we call the function here. It allows us to do that. But then when we are done doing that, so this is the compiling stage. Basically when we are compiling, it consists of three stages. One is pre-processing, which means that it actually processes all of the hashtag commands, hashtag include, hashtag define, everything. These hashtag commands are called preprocessor commands, and when we are actually compiling, it converts that code into object code and intermediate forms called object code, which is not actually runnable by the computer directly. And then a linker takes all of the different object files that we may have, and it combines them together to a single file that we can use. So then it basically the compiler, if the compiler sees a definition that is not implemented, it assumes that it must exist somewhere else in the file, but it doesn't actually check that. And when we are linking, the linker expects all functions that are used to be defined somewhere, and if they are not defined anywhere, then the linker gives an error. No, so now in order to do that, if I along with main.c also put functions.c here, then it actually works correctly. So if you can actually compile multiple files at once using this, say main.c and functions.c at the same time. But even though this works, this is again not this works for small programs, like for example ours right now, but it is actually not the best thing for larger programs. The reason is that when we are doing this, we are compiling main.c and functions.c. Now let us assume a program consists of hundreds or thousands of files. Then that program, whenever we compile it, we will compile all of those files again. However, we are only changing one file. If we are only changing one file, then we only need to compile that one file. We do not need to compile all of the files. So in order to make sure that we don't actually compile anything that is unnecessary, what we generally do is we use there are many different systems. You can just use a Visual Studio IDE and or any other IDE and not have to worry about that. But since we are doing this in just Visual Studio Code, which is a text editor basically, and you can make it an IDE as well, but it's not like that full-fledged. So what you can do is we can use a makefile. That's a common solution. A makefile is essentially a system to compile programs efficiently, and we are going to use that in this video, and that it allows us to only compile those necessary, and it's cross-platform. So you can use a makefile on Linux, Windows, Mac, everywhere. It is supported as long as you have got the make software installed. So now we are going to create a makefile that would allow us to only compile the files that actually need to be recompiled. So in order to get started, let's create a file called makefile, and it's just called makefile, no extensions, no anything, just makefile, nothing else. And let's just call it makefile, and let's create that file. And now in order to actually use this file, let's get started with some basic makefile concepts. Now, a makefile uses its own language, and you can go ahead and create some pretty complicated systems with it, but let's just try to create a simple system for compiling just our own programs. Now first let's learn how to because you can create variables in makefile, because whenever we are using a makefile, we don't just always want to define everything out. We want to have a set of options at the top that we can easily change here to do this. And for that, in order to actually create a modifiable option, we say the name of the option, which is CC in this case, and CC stands for C compiler, and this is a fairly common option that you will see in a lot of makefiles, and this is basically the compiler that we use for C, which our case is GCC. And then there is another one. Let's create another one called C_flags. Now this means that we can of course pass options to the compiler, and this variable represents those options. And in more complicated programs which are using C++ as well, you might see one called CXX, which actually is the C++ compiler, but we are only using C, so we'll just do that. And in here we will only use one option called G, which will actually create an object file instead of creating a executable. And this option will tell it to not just create a .exe directly. And then we are going to provide some flags for the linker as well. We will say L_flags for the linker, and the name of these flags, let's just say that let's just call it we actually don't put anything here, we will put whatever we need later. So with that, then we have got three basic things done. So now let's go forward. So in order to actually make our program work correctly, let's create another variable called bin, which will actually represent the name of the binary file we want to create. We won't just use the default a.exe anymore, so this will be bank.exe. Let's just you can call it whatever you like. And then we are going to create another variable for the build directory, because it's a good idea to put the build stuff, so the actual exe file along with all of the other things like object files and stuff in a separate directory, so that we don't have to worry about that. And we are just going to call it ./build, which currently does not exist, but it will create it when it needs to. So for sources, we are going to create another variable called sources, which will actually represent all of the C files that we actually have. So you might go and say main.c and functions.c, and we can put all of the sources we want here. But there is an easier way to do that. We can use a $sign to issue a special command to make file. Instead of just providing it with a default hard-coded value, we are going to use this, and then we are going to use a special symbol called wildcard, and then put a star.c. What this means is it will automatically detect every C file in this directory, and automatically put those here, so we won't even have to do that manually. Now let's go ahead and create another one called objects, because we will have to create object file as well. And object file, we are going to use the same symbol again, and this time we are going to say sources, and then we are going to put a colon sign. So this essentially means that for each of the sources we have got, we are going to say %.c, which means whatever we want, it can be here. But if it actually is like ending in .c, then we are going to set it to end in .o. So because .o is the extension for object files, it means that, for example, main.c will become main.o and functions.c will become functions.o. But we want to put this in build directory, so we are going to access that variable by putting again this $sign and parentheses here, and in here we are going to say build dir, which actually accesses that variable, and then we are going to put a slash after that, so that it actually puts that in the build directory. Now let's create another variable called depths, which is actually short for dependencies, which will store the header file dependencies of our program. And if I go ahead and create objects, and I'm going to basically do the same as we did in sources, but this time we are going to set it to be .d instead of that, and this is .o. So it will take each of those in the .o here, and we will set that to .d. And since this is in build directory, this will automatically be in build directory. So these dependencies, that .d files, the compiler will generate those for us, and these options that we are providing it will tell it to actually generate those. Now that's awesome, but I'm afraid that this video is kind of getting long, and I'm going to end it here. And in the next video we will actually use these variables to create the actual commands in the makefile that will allow us to compile our program efficiently. So we'll do that in the next video. Stay tuned for that. I will see you in the next one. Make sure to like and subscribe as well, and bye.